Hi, hello everyone. Hope you enjoyed Devnexus so far. I do. Today we'll talk about everything that tends to be unknown or everything that is really new in Java. So from 7 to 15 today. I'm Henri Tremblay. I'm from Montreal. I'm managing the Trading Screen office in Montreal. Trading Screen is a company doing trading systems. We do have an office in New York as well, so if you're looking for a cool job in trading, you can go by New York or by Montreal, because we might hire in both places and in many other countries, but suspecting you're not from these many other countries. So I'm Java champion, mainly because of things I did about mocking, so EasyMock, Objenesis, this kind of thing. I've collaborated to Ehcache some years ago as well. I'm leading the Montreal Java user group, so you can also come say hello in Montreal. And I'm an Oracle Groundbreaker ambassador on top. The logo with the guitar is because I'm an Oracle Code 1 star, they call it these days, which means I'm a good speaker. You will like that, what you will see now. Okay, so going from 7 to 15, I'll try to go not too fast, but I suspect there's a lot of material here, so let's see how it goes. If you want a long version of this talk, I'm on Safari every 2 months in general, so you're on O'Reilly Learning, it's called now. So next one is March 18. So it's the same thing as here, but with 3 more hours. Okay, first little survey by a show of hands. Who's using less than Java 8? It's getting rare. And because of Android or just because legacy? Okay. Who's on Java 8? Who's 11? More hands than before. And who's like bleeding edge above 11? One guy. There's always one guy doing that in a room. Cool. Okay. There's more adoption of 11 than before. That's good to know. It will go pretty quickly. So if I lose you fully, please do ask a question. Otherwise, I'll be really happy to answer them at the end if there's some time and outside and wherever. But yeah, if you feel lost, just tell me that I don't make any sense. Okay, first part, which I call the boring part. It's about the Java delivery process. I like to be like in front of you, but I can't see my slide at the same time. So we used to have a really slow delivery process in Java. So there was a lot of years between all the Java versions. And you might have noticed that now it got much quicker. So every 6 months, there will be a version of Java. Whatever goes in is in. So they just develop stuff and they put everything in there as they are ready. So all these versions are not equals. Some versions are not meant to be used that much. There are versions called LTS, or long-term support, which stands for Oracle will support it if you pay them, and or other vendors actually. But everything in between will not be supported anymore ever after. So right now 9, 10, 12, 13, 14, 15, no 15, 14 is still good, 15 is not out yet. But so 9, 10, 12 are dead already. So nobody is supporting them anywhere. So normally, if you're a sane person and you do not need to be bleeding edge, you will use 8 or 11, which are the real versions that will be supported for years and years after. I think the real number is something like 3-5 years, but actually, depending on how much you pay, you get support forever if you want. Then the way it works is every 6 months you get an Oracle JDK that goes out. The Oracle JDK, unless you're paying for support, is not free to use apart from development. So if you're not planning to pay for any support, don't use that version ever. That's quite a simple rule. Oracle Open JDK. I'm doing a really quick summary, but I saw that Simon Ritter is doing a full talk about that thing if you're really interested. That was this morning, I think. So it's complicated matter. Oracle OpenJDK, that's free. However, they stopped supporting it, so they stopped building it after 6 months. So it's really more to roll over latest versions. And then all the others are normally building 8 and 11 right now. And so Adapt OpenJDK is doing that, but Azul is doing that for Zulu. IBM has J9 and Amazon has Corretto. So you have tons of different flavors, which are almost the same, but sometimes they put stuff in it to tune it or to improve it. So look at the release notes a little bit to see what's different from like the retail OpenJDK. Adopt OpenJDK is retail. So normally there you should get everything you need there, but the others might be tweaked a little bit. And of course, if you do want to pay for support, you just pick your favorite vendor and he will give you an OpenJDK build, but that is supported by them. If you want a long version of that thing, there's a link there. That was written by a bunch of Java champions, and it was like verified by all the vendors, so it should be accurate, and we're updating it once in a while. Okay, enough of that. Another trend you will see in Java now is that we deprecate again. So things are getting deprecated and things are getting removed starting with 9. So watch out if you're using deprecated stuff. The annotation got improved for that. So now you have a since and a for removal. So since means it has been deprecated for that, since that version. For removal means it will be removed. If it's switched to true, be afraid because in the next version it should disappear. So example, when you're a framework developer, you normally want to support 8 up to whatever else, which means that if things are disappearing in between, but because they are replaced by new things, like in this example there, where I'm doing nasty things that people should not do it unsafe, you do need to juggle a little bit to be able to support all the versions. Hopefully, if you're more doing application development, that should not happen to you in general. GCs are evolving a lot as well. So in 8, you have serial, parallel, all, CMS, ICMS. Starting with 8, J1 appeared. It became default in 9, I think. But in 9, they removed the ICMS, which was an incremental kind of CMS, but because it was really hard to support, and G1 is supposed to replace it. In 11, they added 2 things. One is called Epsilon. Epsilon is the GC that does nothing, so it doesn't garbage collect anything. That's used by people who do not want to have the overhead of garbage collection. So they just start their JVM in the morning. They put a tremendous amount of memory. They try to allocate as less as possible, and they hope for no out of memory during the day. So that's the idea. ZGC and Shenandoah right under are more for big heaps. So these are like slightly different flavors of GCs that are more suited than G1 for really big heaps, like terabytes of heaps. So if you are in these realms, have a look because they are interesting. Okay, now features. Java 7. I'm talking about it because it's actually a cool version with a lot of syntactic trigger in there. And also because I think people do not realize how important are the features. So an example of that is the switch. So switch for strings. We can now do a switch for strings, which seems obvious. But there's a lot of light coding, so you will see me code a lot in there. So normally, without a switch on string, it will look like this. So if else, if else, if else. With that version, if you realize, if you're like the 18 if below the stack of ifs, you're the unlucky one that is much slower than the others because you get the 17 first equals called in order. The JVM might play a little bit by shuffling these things, but still there's one loser at the end and there's one winner at the beginning. But it works. If you go in there, and you do a switch like this one, so the normal switch. What actually happens, it's not if else the same way as you might think under the hood. So this actually is more something like this here. I'll just so that's the actual code generated under the hood by the compiler. My laser is probably never, not bad, it's okay. So this is an hash code, and of course, if you cut that by hand, you're a crazy person. And it's just because it means that you have to print all the hash codes of all the strings correctly and then put them in the case. You could put them in some constants above, but it's still kind of nightmarish. So you put the hash code there, and then you make sure, because two hash codes can, like two strings could have the same hash code, so to make sure of that, you still need to do the equals underneath. But as you might notice, when you get there, it will jump at the right place and do the equals all the time. So all cases are now equals and will provide the same performance, which is quite interesting. So that's what's happening. Then, just in case you're not believing me, I will just compile that correctly, and then we'll do this and ask for bytecode. So we'll look at bytecode, and here you see your switch. So you see that's in the hash code right above. But there is something interesting about that. It's that here we have an hash code called. So there is a gotcha in there. Let's run that thing. No, I'll use the shortcut because. So if I had run the test before passing to the switch, these tests were passing perfectly. However, when you go in the switch mode, you gotta watch out, because here there will be a word.hash code that is called. So it doesn't fail into the default because it's null, which is slightly different from before. So you do need to check for null first, and then you can do your switch. So just beware. Okay, so that was for switch. There's other things, multiple catches, for example, where you can put exceptions in the same catch because there's repetition in your catch. That's a nice thing to use if you need to. You'll have access to the methods that are like the closest parent of these two classes. Then autoclosable, which is much more interesting. So before autoclosable, we had to do some code like that. So you create a stream, then you try something, then you finally you close, but then you ignore the exception, which is a bit ugly, but that's the best you can do, so you're happy. The version after with the autoclosable is what you see here. So you have a try, you give the stream in there, and it will magically close under the hood. The fun thing there is that it's much wiser than what you would actually code, because the real code that is created is almost that thing here. So, which means that, and this is what you should actually do. So you do your stuff, then you close. If there's an exception, you try to close again, because it doesn't matter to close twice. If this close is crashing, you add it as a suppress exception of the original exception if there was an original exception, and then you just throw again. So, and if you have like what we have frequently, a buffered reader and a buffered writer, and both are crashing, and you have try and like indented tries like this, it will generate an extremely ugly piece of code that is highly complicated. But now we have autoclosable, so you don't need to do that anymore. You just use the autoclosable, and it will do it for you. So please do it all the time, because it's just better code than what you will be not able but ready to code because we are lazy. There's some other cool stuff about files, so new IO files. I also highly recommend to have a look. I will give an example here of what you can do with. So this is a piece of code, so it's reading a file, and it just tries to put it in a list, something you would do pretty often. So if you try to use most Java 7 features, first you now have a standard char set with UTF-8, so that's a good start. Then you're telling yourself, hey, there's probably a reader in there. So yes, indeed, there is a reader and file, so I don't actually need all these things like this. So now that's better already. From there, we just saw that I can use autoclosable, so let's use autoclosable, which means I don't need these things anymore because I can do that, and then I don't need my close. Here we go. So not bad. It's complaining on file because the new API is using path. So this is path. Path is cool because it knows what operating system you're using, and it will put the slash and the backslash just correctly. So now that, and as you can see, that's already better. But actually, you even do not need to do anything like that because they've added in file something simpler. So you could just do this and you're done. So it's just an example of have a look at new APIs because it might remove a lot of codes you're currently writing. So this is 7, you might already be aware of that, but you have these things all over in all the new versions. Okay, 8. That's a little bit more well-known. 3 seconds about the date API, use it. So don't ever use a date or a Gregorian calendar, ever. Please, stop. Just stop. It's terrible and unusable, and whatever you do with it will take tons of lines of code, and at the end, the result is wrong. Like this is, I think it's 200 lines of code in with a normal calendar. Here, it's just fluent, immutable, works by itself. So just use it, please. I don't want to see the old API ever again. Okay, then lambdas. You all used it, I guess. The only thing I want to say about that is lambdas. So what is a lambda? A lambda is a method without a name. So above, you have a square of sum, which is a method with a name. And under here, you have a method without a name. And the interesting thing about a method without a name is that you have no idea what it's doing unless you read the code in there. Which means that don't go crazy about writing really, really long lambdas because it's unreadable and makes everybody a nightmare. So try to give names to things, but you can use like little tiny lambdas. One-liners are nice. So from there, of course, we can play with them, but that's not what I want to show you because this is boring. What's interesting is what is a lambda. So let's run that thing here. So here it's I'm just looping through the methods of the class where I am now. And of course, I'm only having main here, so it's main. But then I do this because I want to replace with a lambda. And we run that again. And then, ta-da! We see a new method that just appeared here. If you see it here, this thing. So lambda under the hood is it's called the synthetic method. So it's something added by the compiler. Every method that are added by the compiler are synthetic. It's something you can do method that is synthetic and it will return true or false. So lambda is partly a method. But it's a bit more than that. I think I'll need to exit this thing for 2 seconds. Here we go. And we can go back there and run that again. So these are parameters to let me see all the classes that are loaded by the JVM at runtime. So here you will see it running. And we see this thing here that just appeared. So before, when it was an anonymous inner class, you would see in my classes directory a $1 or $1 class, which was the generated class by the compiler. As soon as you go lambdas, these are disappearing, which is interesting, by the way, because it means your jar might be a bit smaller because of that. So a lambda is a method added, and when this method is called, it magically creates a class at runtime. So that's the JVM doing that. And it will put the code of the lambda in there in this little class, and it will put all the closures. The closures is like all parameters that are out of the lambda. We'll see a bit after, in 3 minutes. And so they're passed. They're passed to this class, and this class will stay afterwards to be reused. So the little method, it's called, I'm forgetting the name. Not the call site, is the bootstrap, sorry. It's called a bootstrap method. So there, at first time, it's lazy and say, hey, I need to create something. It creates the class, and it keeps, and it replaces itself with the other code that just calls the class. So that is a lambda. Then, what kind of funny things can we do? One of the things we can do with the lambda is to try to serialize it. So here, I will serialize a lambda. And of course, it's not working because my lambda is not serializable. Here, the lambda is assigned to runnable, so my lambda is a runnable, but it's not serializable. How do we do it? We do that, which is a weird syntax. That was around, but that nobody ever used. But you can actually do a mashup of cast to add flavor to your lambda if needed. So now my lambda is serializable and clonable if I want. So if I run that again, it works perfectly. How cool is that? The rule is you need to have, at the end, you need to have a functional interface. So runnable as run, the other method as nothing. So in the end, you're still a functional interface. That makes sense. Okay, I don't really need the clonable here. The other funny thing is if I do that, let's say I'm adding a here. So this is a closure. So it's something that comes out of the lambda, but that is used in the lambda. So if I run that thing, what happens? Of course, it doesn't work because it's closed. So the class you saw before that got generated as an attribute referencing the closure. And since the closure is not serializable anymore, the class itself is not serializable anymore. So it's complaining about A, but it's the A linked by the generated lambda. So here, obviously, and you go here, and if I do this, it works again. Yay! Cool. Oh, now that's a cool one. Another thing you can do with lambdas, which we'll see also in other versions of Java, is something here. Here I have a little stream and a for each. But if you want to be a bit by the book, you probably know that you're not supposed to code like that. It's not meant to be that way. Normally, a stream should do one thing at a time. Here, I'm getting person and age, and then I'm printing it. So that's bad. So actually, the real code I would like is something like this. And here, and this goes here. Ideally. But then I need to return something here. And I have two things, so I'm kind of stuck. So of course I could do a dedicated class to do it, but that's at the end I might have a bunch of these for no reasons. I could use a new array of object, but that's ugly and not really strongly typed. So here I will do something like this to get it, and so that's just no fun. The actual real cute solution to that is to do the following. You create an anonymous inner class here. You try a compiler who's trying not to be too wise. Am I fine? Yes, I'm fine. It's just that I don't need these actually. Okay. So you create an anonymous inner class. And magically, the compiler will say, okay, map is getting a person and parameter, and it's returning an anonymous inner class. So it will assume that, and it will pass that to for each. And for each will be, okay, I have this thing, and this thing has two attributes. One is called name, one is called cat age, and this works. So perfectly, it compiles. So, and that's interesting because here, there is no way to type that thing. So if you want to type your lambda here, it won't work. It just, because the only thing you have here is object. You could call it type inference 07$1, but that doesn't compile. So you actually have a type here that is untypable. And it's the first time ever in Java that it happens. But it's a cool trick, and it's pretty neat. It creates anonymous inner class. That's the sad part. I do hope they will optimize that at some point and just get rid of it. But now we're there. Method references, I won't go in details because you know the only thing I want to talk about is the special one based on constructor. So, when you call train create, train new here, the train create takes a supplier. A supplier is something that needs nothing in parameter and returns a train. So the constructor that is called is the default arg constructor, which does that. A default arg constructor takes nothing, returns a train. That's good. If you use this one underneath, so this other create, this takes an int function. So it's something that takes an int in parameter and returns a train. So it will actually call the other constructor there, the int serial one. I'm talking about that because watch out. In general, we think it's only the default arg constructor, that is the no arg constructor that is called. That's not true. It's really whatever matches the type of the method taking it in parameters. Then, another gotcha with method references is they're not lazy. So the example is here. Here is just a supplier, and it's doing a s.length, but of course the s is null. If I'm running it like that, it works. However, if I listen to the yellow from IntelliJ and I do this, it starts failing because method reference on a class instance is resolved on the moment the method reference is assigned or created, let's say. If you have a lambda using something that is null, it will be lazily done when the lambda is actually called. So in like 95% of the time, replacing with the method reference works, but watch out for these if what's passed might be null. Okay, I'll take a breath. All good so far? Okay. Wow, let's go back to my slides before I break with my clicker. Code. Okay, let's go to new things, ideally. Java 9, which is not that, so 2017, so it's not that new, but we're going there slowly. The most important thing there were the modules, of course. Little things are the try with resource. Now, if you get a stream in parameter and you want to close it, you can, because before it wasn't possible. You were required to define it in the try, to define your stream or your closable thing in the try. Now you can just put it there and it will close magically as well. So this is a little improvement over the original concept. There's another cool thing. For those who use that, please don't. That's ugly and terrible. I hate you. It just creates anonymous inner class and like subclass of hash maps, and it's terrible. So don't do that. In 9, you have this. So there's a map of, but there's also list of and everything of, where you can nicely instantiate your thing. It's immutable, however, in the end, but that's in general what we want when we use the mustache. If you can't use Java 9 or later, You can do this. That's the quickest thing. It's like 4 characters more than the other, but it's not ugly. One other addition is the private methods on interfaces. This is mostly to reuse code in default methods. You will seldomly use that, but it's there for like preventing cut and paste. So just know it. And of course, in Java 9, the big things is modules. So the idea behind modules is that things should depend on other things, and it's really clear what depends on what, which means that you're not in a random class path. You need to explicitly say that you want to use something from another module to be able to do that, to do it. The cool part is that in the JDK, they were able to do a tremendous amount of cleanups with that because JDK after 20 years was looking like a big spaghetti, and they managed to make it as nice modules. Out of the JDK, adoptions for modules are not that good. Anybody's using modules here? Yeah, that's expected. Anyway, I'll quickly talk about it still. The concept is nice. It's just that all the libraries are not there yet for many complexities. We'll see a little bit of them. This could be a full talk, so I will go really quickly to show you the idea. So modules, there's like 2 flavors of them, 3 flavors of them. So the first thing, let me get my terminal. Where are you? Terminal. Here, sorry. Here. Okay, terminal. You're here, and then I do this, and I go Java 9 here. Okay. So if I open that thing, so normally we use the class path, we have things in it, and it just runs. Concept with module is you have a brand new syntax to tell that you want to use modules. So you give a module path, then you give all the modules. You will notice that I give target and not classes because that's slightly different. A module path is a bunch of directories where they can be modules. It's not a specific jar. So you can now just put your jars in lib and tell, hey, that's my module path, and the JVM will figure it out. And then -m is for main. Here you give the module name and then the main class. And if I run this, 2 version, I need just to clean up, because I had an old version. There we go. Okay. So you might have noticed that I've done nothing and I'm already a module. If you want to look at the class, so the class is app. It does some method handle thingy. Method handles are something that appeared in Java 7. It's like a faster and more advanced kind of reflection. So if you want to play, you can use method handles instead of classical reflection all the time, and you should get better performance theoretically. Something I cover in the 4 hours version. And then anyway, so app is using hello, and hello is just printing some stuff, and I'm fiddling with name, replacing it by Henri by reflection to print my hello Henri that you see here. So by default, everything is a module. It's an auto module with a name that matches the name of the jar. So it will take, let's look at the jar actually, that will make things clearer. App, here we are. So here's the jar. So by default, it will replace the dash here by a dot. So it becomes java.app. It will throw away the version. They decided that like everybody's using the Maven naming convention though, so that should work. So it throws away the version at the end. Modules are not version, it's not like OSGI. And you end up with the module name. When you want to use module, normally the first thing you do is to give actually a real name to your module because it's really that one that you want. So if you're EasyMock, you do not want to be the module EasyMock, you would like to be org.easymock because that's the real package name. So if I uncomment that code, I can give an actual module which will end up in the manifest. I won't do that because we're slightly short on time. But that's the way you would do it. And this is Java 8. So, and now we're going Java 9. So until that moment, you could be in Java 8 and be module nicely compatible. However, if you start to actually really use modules, you go here, so, and you add a module info in your project. I'll open it, and then where's lib? Here, lib is there. Yoop, and what's the time? Oh, okay. I'm trying to be fast. Here we go. And so that and module info is that's kind of nice for those who did OSGI. It's really different because that thing is compiled for real, and IntelliJ will be aware of it. So you give a module name, then you export the package you want to export. So this is a package. On the other side, if I go to the other one here, on the other side, you will require another module. So I'm requiring lib here, and I have my module name. And all these things are strongly verified. So if I gave random names to things, it's read and tells me this module doesn't exist. If I try to require something that doesn't exist, same thing, it won't work. Or if I go, or if I comment that out and I try to compile, it won't compile anymore because hello is not found and I'm a module because I'm not requiring the thing. So that's pretty neat actually. It brings really serious dependencies in your between your different jars in your application. One interesting thing is that if I run that thing, new. I'm getting my terminal. I forgot my terminal shortcut. It's out. Okay, getting back my disappearing terminal. So just recompile quickly, and then where's my run? So I've changed the name. So now we have the new name of the modules, and sorry, stupid me, and then I run that. And so the interesting part is now it crashes. So a perfectly working program is now crashing. Why is it crashing? Because of this thing. There's something funny is that you can require a module, it will compile perfectly, but that doesn't allow you to do deep reflection in there. A module to allow deep reflection needs to say that it wants to be deeply reflected, which you will see here. So one of the solutions is to open yourself. You can also pass parameters because it's not that easy to know that you will be open to something in the end. So you can pass JVM parameters, and that's kind of complicated and ugly in general, which is one of the reasons why many frameworks like Spring Hibernate, it's a mess when using them because they're doing reflection all over the place and you do not necessarily know what they're doing. Okay, so that was quick module. Java 10. From now on, if you go on the internet, you will see for JEPs a full description of what's in there. I tried to put in bold what's actually really interesting for like normal developers. And I have 20 minutes, not so bad. Okay, so here, there's GraalVM that starts to be more there. If you've seen Quarkus demos or any things about it, it's an interesting just-in-time compiler that should replace Hotspot at some point. I won't talk about it here. The other really fun stuff is called local variable type inference, so var. And var is that thing here. So the idea is, this is super long, I don't want to use that. I would like just to, and I do know it's an hash map anyway because it's all written here. So I'm replacing the long thing I had first with var. Of course, now it's not compiling anymore because this had some cute typing here. And var doesn't have that cute typing, and Java is still, so that's not JavaScript. Var is not, I'm a random variable. The type of var is inferred by whatever is on the left side. So diamond operator is not possible. You do need to type on one side of the equals. So you're now forced to do it here, but you just save like the concurrent hash map thing on the other side. The other thing to notice is that now the type of var is concurrent hash map. It's not concurrent map anymore. So it's not the interface, it's really the object. There's no interface guessing in there. So now you have access to the method of the implementation, which normally doesn't matter because you're in your little function. You can only use var in a function, in a method, so not as an attribute, for example. So you're in a limited scope where you do know what are things. One thing to watch out is, of course, since the type is not implicitly in var, if you do something like this, you do need to go look at getMap to make sure what's the type. So do not use var like crazy because readers of your code will go swim to see what's the type of the object they have in front of them. If it's not extremely obvious what is the type, just type. Do not use var. Okay. So then, if you're wondering, var is not a keyword because we stopped keyword since Java 5 because enum was a new keyword added and everybody screamed that it was breaking their code. So they decided to not add any keyword anymore. In Java 9, they broke that hold, and they decided that you could actually have, so that underscore will become a keyword. They want to use that for pattern matching. So you're not allowed to have a variable named underscore. That's fine, because if you name your variable underscore, you're an evil human being. And if you still want to be evil, you can add more underscores, and that still works. So evilness is still allowed. But var is not a keyword, so var is will be special when on the right side and become a var, but actually you can still use it all over the place. So you could var things, for example. Here we go. Okay, and so it's called, what's the name? It's called a reserved identifier, which is a like grammar thing, so you don't really need to know that. The module things were restricted keywords, so all these new keywords and modules, module info, are restricted to the module info class. If you're using something called module anywhere else, it works, of course. Okay, then let's go here. The other cool thing you can do with var, it's here. Here I'm using my old tricks of before. So I have ID and name, and instead of printing it out and for each, I'm collecting it. So now I'm collecting an anonymous inner class. And of course, if I want to type that thing here, I can do object, but that's the only way I can type it, which is sad. However, if I type it at var, that works. Isn't that cool? And so if I do get of 0, for example, and I get my name here, ta-da, it's there. So compiler is keep inferring, and it's just, oh, that there's a var there. My type is object, anonymous inner class, blah, blah, blah. So I'll keep working correctly, and you can just play with it along and pass it around, and it magically works. So more and more we go in later Java version, type inference is getting wiser and wiser, and things are getting weirder and weirder because the type is not as obvious as it used to be. And you can have variables assigned to unknown types. It's strange, but it's cool. Okay. 11. 15 minutes, not bad. So 11, you have HTTP client. So there's a new HTTP client to do HTTP requests and things that was built in that thing. It's quite nice to use. So if you need to quickly do like REST calls or things like that, I won't use it for big full-fledged application, but if you just want to do little things with it, it works nicely. The other thing, so local variable syntax, where do I go first? Okay, I'll go. These should be around. Okay, let me go there. I'll go that first. So they've added the idea that, so here, as we saw, you cannot type, I need the other mapping. Let's call it tuple, and I will just return tuple like this. So it's useless, but it's to show what I want to show. So as we saw, you cannot type this, and they noticed in Java 11. So in Java 11, they're now allowing you to var it. So before that, it wasn't possible, but now you can use var to type the lambda parameter. Then you will ask me why on earth would I want to do that? That's because it's actually allowed to annotate lambda's parameters. And it's not possible to annotate if you do not have a type. And since it wasn't possible to have a type, it wasn't possible to annotate. So now you can, if you ever wanted to. I don't know. Okay, and now we're going to one of my favorite features in Java 11 and in many versions we saw so far. It's called a single file program. And the concept is that, let's say you have this class here. So that's a Java 11 class, and it's printing stuff. And I should have changed that because that's not here. We are here. Better. And the cool thing is, starting with Java 11, I do not need to compile the class first. I can just run the Java class directly. If needed, I can put in my class path whatever library I want to use. There's only one Java file, so I cannot like put tons of them. However, I've been using that for 2 or 3 days now because instead of having a terribly ugly bash script, I'm just coding my scripting, my delivery scripting in Java. I'm super happy because I love Java. You could use some other scripting language, but it works with Java. Why not? It's all on all my servers, so it works really nicely actually. I'm really happy about that. So do not do any bash anymore. You can do Java. Woohoo! The other cool thing is that you can do this here. So if you put the code in a shell .sh and you put the shebang at the top, telling to launch to use that executable to launch your Java code, you can actually also this will also work. I don't know. Will it work? Yeah, it works. I haven't. Again, Devnexus. Here. Yeah. So you can even do a real shell, but I do not actually really recommend it because it's clunky to code. But you can, yeah, I don't know. But if you want to hide some Java in actual shells instead of doing bash, you can. Hey. Okay. 2019. So that's getting nearer where we are now. So they've added one thing, which is called switch expression, or one thing that is interesting for us. And it's called the preview. So that's new. The concept is that they will now put new features that are not that dry yet. So you should not use them for real production code because they might change a little bit afterwards. It's not that they're not working, it's just that they're not final. So switch expression was a preview in 12, and when they think it's ready, it's released for real. It is actually a good idea because we can have a look at it. And even decided to extend previews a little bit more so we can really get our hand in it and make sure it works. because before it was a bit too quick. Because as you know, if something goes in Java, it will stay in Java forever, ever after. So we really need to make sure that we do not screw up the feature. So switch was the first one to be like that. You will see, not this. There's more in later version, as you will see. So the idea is to have, this is an old switch. If you're a quick reader, you might have noticed a break was missing there, which is happened quite often with switches. And this is the almost switch expression one. So you replace the colon with an arrow to, where's my here? Here to return, to assign your value. And you can put many cases one time, so there's no break anymore. You just put many cases one after the other, and it gives you something super dense and quite nice, actually. Why is it called a switch expression? Is because it's an expression, so it's not an imperative code. The switch is now returning something. So you could actually directly assign the result to your variable instead of assigning like it was right before. So you just put true and false there, and it does the exact same thing. Expressions, I'm guessing, will happen more and more in Java. Other languages like Kotlin are doing, everything is an expression pretty much. Not sure Java will go there, but I'm suspecting we'll get more of that. Yeah, so I could just do that. So that was 12. It was a preview. It's still a preview in 13. And in 13, they actually modify it. So now you really realize that previews are previews. They might move. So in 13, they decided that you could yield, because if you have a lot of code, you could not return because you're returning out of the method, not out of the switch. So you needed, there was a lot of fighting, should we break with something, but that was messing with loops that you might break out of, so that wasn't working. So they decided to add another keyword, which is not a keyword. And so you can yield to just get out of your switch and returning a value if you need to. Okay, and it's still a preview. I forgot one thing about previews. Will you see it? It doesn't matter. To use previews, so previews are disabled by default. So if you want to use them, you need to use a -- enable preview, enable -preview. At compile time, so to compile preview features, you need to tell you want to, and at runtime, you need to tell you want to use runtime features in Java. So if it's a library compiled with previews and you're using it, you need to allow the previews on your side as well. And you really want to make sure you know what you're doing. Okay, the other thing that is a preview in Java 13 is a text block. Text block has been awaited for a long time. And of course, the idea is to look a little bit like that. We'll show you a demo, but after we go to Java 14, because again, it evolved a little bit. 5 minutes, okay. This was 1 hour before Java 14 appeared, and now my life is complicated because 14 is a nice version. There's a lot of stuff in there, as you might notice here. So I'll magically try to go through all of these in 5 minutes. Let's see. Okay. Ting. So the first one is the text block, and here is an example. So that's old school Java. And IntelliJ will let me transform, and it doesn't, your eyes have stopped bleeding while looking at the code now. The way it's working, so we can run that. The way it's working is that everything here is not considered, so you can see the printout here. So everything, like, it takes the character, the character on the more on the left of the full text block, and that's the beginning of everything. So you can indent your thing correctly. You're not forced to do this. If you want to play with that, go read the JEP. It will explain all the rules, because So it starts with 3 double quotes, but it needs to be on its own line, so this doesn't work, for example. Then the other one here there's a final line feed at the end, but this can go here, which means that there's no final line feed. So they are like different rules that in general will make sense, so you will just do it right first time. But if you want to make sure what you're doing, just go read it. It's like 1 page to read. Of course, you still can do things like \t in there to add tabs. There's a new one called \s to add trailing white spaces. This is more to help IDEs, because if you do not put that here, there's high chances that your IDE will do this. So to make it obvious that you do care about these final spaces, there's a white space there. And they've added, this is in 14, they've added the \/ to do multi-line. So this is actually one really long line, and it's written as one really long line, but the \/ allows you to put it in multiple lines, which is pretty nice. Okay, that was the text block. Helpful MP. Okay, this is something that should have been in Java 1. So the idea is you have a null pointer exception and you have no clue if it was get value or length that was actually, so if it was A or the return of get value that was the null thing in there. Again, I need to get out of here. And so it's not enabled by default, sadly. So you need to add this incredibly long parameter. But if you do that, let's go back here. Please give me my output. Here you have this. So now you have the same exception, but you have this little part added. Cannot invoke string.length because return of value of, please scroll faster. Because value of A get value is null. So it's super clear what was null at that moment, and it is tremendously useful. I'm eager to get to Java 17, which is the next LTS, to be able just to use that thing. Okay. Pattern matching. What was the number? 18. Okay. Another thing is, so they started to do a little pattern matching. This is for this idiom. We frequently do an instance of string like this, and then we print and we need to cast, which is slightly stupid because we do know it's a string. The compiler should figure it out because we just checked it was a string. So from now on, you can just add a s here. This is the name of the new variable, and you just replace by here. So if it matches the pattern of the instance string, it goes in the variable, and then you can use the variable. So it's more like syntactic trigger, but it's also a first attempt of pattern matching, and the plan is to use it more and more afterwards. Okay, finally, am I late? Yeah, but you're still interested, all good? Okay, we'll do it. Last one is record. So record is the idea that you have this class here with final and points and a constructor, and then you have an x, and then you have an y, and then a y, and then you have, sorry, it scrolled quickly, and then you have equals, hashcode, da. So that's super long. And it's something we do quite often, actually. So in Java 14, they decided that this is not needed anymore. You can do record point int x int y, and that replaces almost entirely the code you saw below. So it's immutable. There's no setter generated. The getters are called x, so it's not get x, it's called x. But equals is implemented correctly with x and y in there. The hash code is the same. The only thing that would not work in my version here is the toString here. So the toString will be an ugly toString with like point and square brackets. I should do it actually. Let me run that thing. Here we go. Let me run that. So that's not as nice as my original toString, but you're allowed to override. So these classes are final, so you cannot extend records. However, you can override methods in there. And you cannot add attributes as well. So if you want some like lazy attributes, it won't work. But if you just want like a straight immutable Java bean, it works and saves like hundreds of lines of codes. So it's cool. I think I'm done. Yeah, I won't do that one. In Java 14, they added something to package. I won't do it, but I can show you quickly the idea. Here we go. So there's something called JPackage. It's an incubating feature, so it's not that dry yet on that production ready again. But it allows you to create an executable. So if I run it here, it will create a DMG on my Mac, and I will be able to have a fully running application from there. So it's pretty neat. When used with JLink, which is a thing to look at dependencies, you can actually create a JVM that contains only the modules required by your application to get a much smaller application. If I use the full-fledged JVM, this thing is, I think, 300 megs. And if I use the cut-down version with JLink, it's 128 megabytes, something like that. So, so you got a real app that you can give to people, and it's running by itself. So there's no JVM that needs to be installed on the machine. Depending on where you use it, on Mac it's DMG, but if you're on Linux, you will end up with a Linux executable, and on Windows it's executable, so .exe. Here we go. Java 15. There's nothing in there so far, so there's. So you will be good to go. Yeah, it's not. Yeah, I haven't decided of any fun features yet. Okay, question I'm asking all the time: who has learned something today? By a raise of hand, please, to see if I should retire or not. Oh, that's almost the full room. Good. There's some links. There's not much about really new stuff. So there's a bunch of Java 8. There's modules, different things, but new stuff is too new or moving a bit too fast, so there's no book that I'm aware of. Heinz there does nice online courses if you want to go deeper, and he tends to use latest JVM, so you can see all these features in action. Some books as well. Again, Core Java is maintained frequently, so it will talk about later feature in general. And here's where to reach me, and if you have any questions, please do ask right now, actually. Thank you very much.